Hello everyone, thank you for registering for this tutorial and I'm happy to see you all here. Today we'll be doing a landslide risk analysis of an area, and the area that we chose is Granada. We chose this area because it has all the files that will help us to do our analysis and do all the risk analysis that we want to do. And a little bit about myself, a geotechnical specialist. Also interested in doing GIS stuff, and so that is why we are here today. So without wasting much time, I want us to dive deep into how this is done and how to go through all the processes and how to do everything. So yeah, let's start. Thank you. This is ArcGIS Pro, the dashboard of ArcGIS Pro, and for those who have not used it before, we have to first create a project of where all our data will be going and where all our analysis will be going. And so that is what we have to do first. And so the first thing that we will do, if this is your first time using ArcGIS Pro, is to go to project. We go to new and then map, and then you create a new project. You give it a name and then you choose the location. The location you choose is where we will place all the data files that are sent to the group page. You have to bring all those files into this project so that you can easily bring it into the project that you are working in ArcGIS Pro. So that is how we create a new project. Without it, it will be difficult for you to track the exact location of all your files, and the end of it, when the analysis is done, it will be difficult to track where each conclusion that you made and each findings that you made will be located, because it's sometimes difficult to know the exact location of the output file. So you just have to find a location where it's easier to find, and then you put all the data into it. You create a new project and you place it in that same project for your work. And so with this one, I have created a new one. You can also create a new one. You just go here, you type the name, you choose a location. If the default location they've given to you, you are okay with it, you just click on OK. So I already have a project, so we will continue working in that. So now we want to learn how to bring in your data that you want to process using the deep learning framework that ArcGIS produced. So we need 4 types of data. One, we need a satellite imagery of the area that you want to do this analysis on. The next one is we need an elevation map, kind of showing you where there are high peaks and where there are valleys and low areas. The next one that we need is distance to rivers, because the distance to rivers can affect the soil type in the area. And so we will need distance to rivers as well. And then we will need land use. So where we've built areas where there is agriculture, where it's just a forest, a virgin forest, we need all of these places. And so it's difficult to get all of these 4 data for a particular place. So you have to continuously be searching. So you are lucky if the area that you want to do your analysis on, you are having the satellite imagery or the LiDAR imagery, we are having the distance to rivers, the elevation and the land use. And so the only thing that you can do is to continuously be searching. So I found a place which is having all of this data that we need, and that is Granada. When you go to South America, there is a small island here called Granada. We are having all the features. And so if you want to search for these features in any area, the first thing that you have to do is you go to view, you click on catalog pane. So this will appear. You go to portal, and then you go to ArcGIS online. So with this, you just come to search, and then you search for what you are looking for. So because I said I already downloaded the Granada data, which I have sent to the page, any area that you want to search, you can search it here. So maybe I come here, I search Granada satellite imagery. I click on enter. So we are seeing it here. We are lucky. The next thing that we have to search for is elevation map. So Grenada elevation map. We are seeing that as well. We are seeing Grenada elevation. You can see it here. The next one that we have to search for is you have to search for distance to rivers. Grenada distance to rivers. We are seeing that here as well, distance to rivers. And then the last one you have to search for is land use. Grenada land use. Search for that. We are seeing Grenada Sentinel-2 land use, which we can use. So if you want to download this, if you kind of move your mouse on it, you can see a link here. You click on the link, it will send you to the location where the person who owns this data is having it located. So sometimes they allow downloads, sometimes they do not allow downloads. But then if you want it in your map, it's easier to do it. You just right click on it and add to current map. So anything that you are seeing here can be added to the current map without being downloaded. But if you want to download it, you can go to the link and download it from that link. So we will be opening all the Grenada files that I have sent to the page. We'll be opening it and then we'll be doing our analysis on it. So I have already sent it to the page. You can go in there, download it, create a database, add it to the database, and then we will start working. So our next thing that we'll be doing is we'll be bringing in all this data and then we'll be working on it and start our analysis. So we will now learn how to work in the project. So there are two ways of doing this. The first way of doing it is to just double click on the downloaded file that I sent. So the downloaded project, you can double click on it and it will open ArcGIS Pro. The next thing is if you have an ArcGIS Pro project already created and you want to just bring this one in, you can also go to ArcGIS Pro and bring that one in. Another option is you can just go to ArcGIS Pro, go to project, and then you bring in this package that we've given you, and then you start working on it. So I will go with the first option. I will just double click on it, and then it should open ArcGIS Pro. So when the project is open, you should see Grenada. That is the location where we want to do the analysis. However, if it's not opened, it's at the northern portion of South America. So you see Grenada at the northern portion of South America. This is the hill shade map, so it's a bit, it's taking a long time to load. So that is Grenada. If it's not loaded, you zoom out to the whole world. And it's at the northern part of South America. So that is Grenada. So if you have any other place that you want to work on it, as I mentioned during the beginning of this tutorial, that you just have to find all these files that we need to be able to do this Landslide Susceptibility Map. So that is where we'll be working. When it opens, you should be seeing this. You should be seeing two tabs. And then for the first, the building extraction, footprint extraction, you should be seeing this in the susceptibility analysis. You should be seeing the soil types, the elevation, the distance to river, the land use, and you should see the world topographic map and world U-shaped map in it as well. So we'll be working on it. As I mentioned, if you want to open it whilst you're already having your ArcGIS Pro opened, you have to go to project and then open another project, and then you go to the location where the project is located and then you bring it in. So that is how it's done. So the first thing that we will have to do is to create a Mosaic Dataset. So the Mosaic Dataset is serving as a bucket or as a placeholder for all the area images that we have at Grenada. So the Mosaic Dataset that you'll be creating will hold all the imagery that we are having in Grenada. And so we will go ahead and create it. So the first thing that you have to go is to go to the view, and then you go to the catalog pane, you click on it, and that is the catalog pane. You should see, if you have opened the project that I sent to you, and you have a location where you've opened it, you should see the Grenada landslide. You go to common data, you can see area imagery of the Grenada area. We are having about 16 images, area images, that we want to kind of upload onto the Mosaic Dataset that we want to create. But first, you have to create an empty Mosaic Dataset, and that is what we'll be doing now. So the next thing that we have to do again is, in the same area, you go to geoprocessing, and then you search create Mosaic Dataset, which is here, and then you click on it. So this opens, and then you choose your output location wherever you want the output file to be. You choose it. So you click on this. I have my database, and so I have my Grenada dataset. So I click on database like this, and then I click my Grenada dataset, and then I click OK. And then the Mosaic dataset name, I will choose the name that I want to give to the output file, and so I will say Grenada area imagery. And then the coordinate system, we will be choosing WGS 1984, UTM zone 20 north. So we click on this projected coordinates, world zone series, UTM 1984, we are in the northern hemisphere, 1984, UTM zone 20 north, and then we click OK. For the product definition, we will choose none. For product properties, you will leave it as it is. You will not be adding the appraisal properties. You will leave it as it is, and then we click run. It will take a bit of time to finish based on the speed and capability of your laptop or desktop that you are working with. So now it's completed. We saw the notification that came, is completed. We have our Mosaic Dataset created, which is in the Grenada landslide. We can see it in there. However, there is nothing in it, so there is no imagery or whatsoever. It's just like a placeholder, but then there is no imagery or area imagery that we've added to it. So that is the next thing that we'll be doing. We will be adding the area imagery, which is these 16 area images. We will be stitching them together and adding them onto the Mosaic Dataset that we created. So that is what we will be doing. So the next thing is, we added the query, the Mosaic Dataset to this Grenada landslide database. So we click on this Grenada area imagery. We right click on it and we click on add rasters. It will now add the rasters that we are having into the Mosaic Dataset that we created. So Mosaic Dataset is Grenada area imagery because that is what we created for the Mosaic Dataset. And then the raster type is a raster dataset. Processing template, we have the default one that we are having in the ArcGIS package that they give to us. So there is this AI packaging they give to us. They have a template itself, which I also sent it to the page for you guys to install onto your ArcGIS Pro. So we have a processing template in it already. And the input file, if you want to select the files itself, you just click on file. But then for me, what I usually do is I select the folder. I select folder, which is optional. I feel that is the best one. I select the folder because all the imageries that we are having for the LiDAR imagery of Grenada is in that folder. So I select the folder, I just click on that folder, and everything that is in that Grenada data set as a LiDAR imagery will be added to the Mosaic data set that we've created. So I click on this, and then I click area imagery because that is where everything is located. When I double click on it, I open, there will be nothing in it because I chose folder here, so you will only be seeing the folders. So I go back, common data set, area imagery, and I click OK. So it will pick everything that is in that folder, and then it will work on this. So advanced input sets, data options, we won't do anything here, but we will go to raster processing. Maximum level is which maximum levels are you setting for your imageries to be added to the query data set? We don't know the exact features of the LiDAR images that we are adding, so we will not put anything there. The maximum cell size, we will put 0 in there. Minimum rows and columns, we put 1005. We've seen that this works the best. And we'll go to Mosaic processing. What we will choose build thumbnails and update overviews and estimate data set statistics. So these are the 3 things that we'll be choosing. We are choosing build thumbnails, update overviews, and estimate Mosaic data set statistics. So that is what we are doing. So if you have all of this, you created your Mosaic data set and you have your area imagery and you've added it to this, you've put in these figures, you've selected all these checklists that I have selected as this, you are okay to click run. And this will also take a bit of time depending on the capability and the speed of your laptop or the computer that you are working with. And so with all of these things entered, you click run. If you have different places that is having your area imagery, you can be adding more of it by clicking on browse, add. So it will be listed here, showing all the places where you are having your area imagery. So we click on run and wait for it to complete and give us a report. Run. So after the processing is done, the images, the area images that we had will be stitched together to create a new image that will be added to the Mosaic data set, the empty Mosaic data set that we created. And so when we look at Grenada, these were the 16 images that we were having. So this has been stitched together to form one satellite imagery, which we can do analysis from. So it is in this filled up Mosaic data set that we will be doing the building extraction from. So we can zoom in and see images of buildings, and so we'll be using the AI tool to detect all these buildings in a polygon form, so we can do our susceptibility analysis in this whole area. So when this thing is completed, you will see add rasters to Mosaic dataset completed. You will see a notification here. So it means it's already added to the empty Mosaic dataset that we created. So the next thing that we have to do is to extract these buildings in the form of polygons for us to be able to do analysis, because this one is just like an imagery. But then we need polygons of all the buildings to be able to do our analysis on. So the next thing that we do is to, we can close this one. The next thing that we do is we click this arrow, this back arrow, we click on it. And then we go to toolboxes. And then in geoprocessing, you will see image analyst tool. So you go to image analyst, detect objects using deep learning. Input raster will be Grenada area imagery, and then I'll put in Grenada buildings detect. you choose the location in the database where you want to put your output file. So building detect, and then the model definition. There are two ways of doing this. You can search for it in Living Atlas, and then you go to building extraction. You should see building extraction USA. You click OK. That's it. Another way of doing it is you can also go to that same location, and then you go to Living Atlas. You search for detect buildings. It will come detect buildings USA, but then you kind of move this button until you get to the location, you get to the link of the owner or the person who developed this. So building extraction USA, the third one, you go here and then you click on this. If you click on this, it will send you to a website, and so if you are able to log into your S3 ID or S3 credentials, you should be able to download this. And so you download this onto your personal computer, and then when you get to this point, you can bring in the downloaded file straight away in here instead of downloading it from the Living Atlas. So that is another way of doing it. And then we put in these values. We've realized that these values helps to get an accurate detection of the buildings. So padding is 128, the batch size is 4, confidence threshold is 0.6, putting 0.6, bounding boxes is false, test time augmentation is false, merge policy is mean, and then tile size is 512. So if you have all of these done, you just click run, and then you, based on the speed of your computer or your desktop, you wait. I've seen people working on this, and it took them like 3 hours, sometimes 4 hours. So you just click run, and you just wait until the whole project gets completed, the whole buildings are detected, and then you can go ahead and do your susceptibility analysis. So you go ahead and then we click run. And then we can try the environment as well. The environment, we usually want to keep all of this. We can also choose the coordinates as we chose before, but then that one is already in the area imagery, so it knows where everything is. And so there's nothing much to change here, unless there are specifics of what you want to see. So with everything entered here in the parameters, that should be able to detect all these buildings and create a polygon for you. And so we click run. We wait until it gets done, and then we continue with our analysis. So once it finishes doing the building extraction, you should be able to see something like this. So we have the imagery that was added to the empty query data set that we created. But then when you zoom in, you can see that most of the buildings, there is a polygon that has been used to create kind of a polygon above the buildings that we are seeing. It might not be perfect, but majority of the buildings, you have something, a polygon on top of it, because you can see that in this area, these small structures that were here, only this one was picked. The remaining ones were not picked, and therefore there was no polygon that was created for it. But then in the other areas, you can see that all areas that there are houses, there has been a building polygon that has been extracted for the satellite imagery that is in that location. So now we have this. You just have to pan in to see how perfect your building extraction was. So we are seeing it did a good job. Yeah, it did a good job for me. So we'll have to go ahead and create our susceptibility map, and then we will know, with these polygons that we have, we will know places where there are it's at risk of landslide should a landslide happen. So one thing that I usually want to change this the color. To a different color, like blue. So all the buildings that were picked has a coloration of blue. It will be easier to know after we do the susceptibility map. It will be easier to know where, because if the color that you chose blends in with the susceptibility map coloration, your output image that you are having will not have much value to you or to anyone that you want to send to. So that is one thing that I will do. Afterwards, you go to the susceptibility tab that we are having on the other tab. You have to just go through to understand what each one is. So when we look at the elevation TIF is just kind of places where there are low elevation and high elevation. And so if there are steeper slopes, the steeper slopes will have a higher susceptibility of landslide, because steeper slope, which is not having the angle of repose, will be easier to fail and therefore stand a higher risk of landslide susceptibility. The next thing that we look at is soil types. So the soil types, so the more clay the area is, the more it is to landslide susceptibility. So that one too must be considered. And then the next is distance to rivers. So areas that are closer to rivers will have a higher susceptibility to landslide, because if the area is close to a soil, the area is close to an area which is having a steeper slope, the soil is clay. It means the clay material can be saturated with the water that is in the area, and therefore it will be easier for a flow to happen and therefore a failure. And so that is one thing that we want to be considered. Also, the land use, areas with roads, buildings, and areas that are artificially vegetated are at a higher risk, but in places that have forest reserves, places where there has not been much disturbance, has a lower risk of landslide susceptibility. So these are the data that we will be using, and so we have to be conversant with why we are using all of this data that we have. So the next thing is to go straight away into doing our analysis and see if we can combine these features that we are having to create a susceptibility map. So you go to imagery, raster functions, and then we click on raster functions again. So this is what we will be using as soil types, the slope that we are having, the land use that we are having, the distance to rivers that we are having. This is what we will be using. But before that, let's close this. So the next thing that we want to do for us to understand the function that we'll be using is the same raster function. Click on the raster function, click on this, and then you get to project. This project is what was created by ArcGIS, who walked us through this tutorial for us to be able to understand it. But this is how it's done. So you go to Landslide, you want to understand how it is done, how ArcGIS Pro is able to combine all of these 4 data that we are having to create a landslide map. So on this, you right click it, then you click edit. So this is the whole idea. So we have the soil types, we have the elevation, distance to rivers, and land use. So if you want to add a raster layer, you just click on this, and then you choose the type of layer you want to add. And then these are mathematical functions. The yellow ones, the green ones are the raster layer that you'll be importing, but the yellow ones are mathematical functions that you want ArcGIS Pro to do on the data that you are giving it. So normalize, remap, normalize soil. So kind of what this will do is it will use the soil types that you give to it, or the data that you give to it. It will renormalize it and give it a value that it is able to process as the process is going on. So the soil type you give it, it will create a value for it, and then it will use that value to do further calculations. So we go to the system. If you want to normalize, you see remap. So remap, and then you bring it in, do this, and then you add to function editor. So this one will now come in, and then afterwards you arrange it into the format that you want. If you want attribute table, you just go to systems, attribute table, and then attribute table, add to function editor. Then you can add it here, and then you now follow the workflow to be able to create this landslide editor that we are having. So this is what we are having. We will have the soil type, elevation, distance to rivers, and then we are using the functions that we are having in the raster function. We will remap the soil, we will give it specific values, and then it will use that specific values to calculate it. The elevation, it will calculate whether how steep or the slope is. The distance to rivers, it will calculate the distance to rivers, and then it will give it normal value, the same with the land use, and give it normal values. It will weight all of it, it will classify the results, and fill an attribute value with the data that the calculation is done all this while up to the classified results, and then it will add it to an attribute table. So now we understand how the raster function is. You should be able to see it in the data that I sent to you. So that is it. This one, if this one is not appearing, what you can do is this. You go to a raster function, and then you go to custom tab. You should see this custom, and then you click import functions. You click import functions, and then you go to select processing template. So this is the select processing template, and then you go to folders. Let's go to folders. Grenada landslide risk. You go to P30. You go to raster function template, and then you go to Grenada landslide. So if you are not seeing this when you click on this, that is the process to follow to see. You click on it, and then you click OK. You should be able to see it now in the project tab. So we click on the project tab, then you double click on it. So if you double click on it, these are the things that you will see. The same process, you can follow it in here. You go to imagery, you go to raster functions, and then you click raster functions. You should be able to follow the same process here as well. So the next thing that we are doing is to bring in the tabs. Because you are in the susceptibility analysis tab, your data that you are using should all appear here. So you click on, let's close this one. So you click on soil types, because you're already having it in this contents tab. So you click soil types. Slope, you click slope, elevation. Land use, you click land use. Distance to rivers, you click distance to rivers. And with that, you are almost done, because the remaining ones, you just have to allow ArcGIS Pro to continue with the processes and just wait until it's finished. So what you want to do is we want to create, it's a raster layer you want to create. We want to create a new layer to kind of bring in the susceptibility map. And then afterwards, we are done. So we now click on create new layer and see how ArcGIS Pro will continue with the process and bring out a raster layer, after which we will compare with our results and see what is what the output file is giving us, if it's true or not. So we click create new layer. So we wait for it to finish creating a new layer. So once it's completed, you should be seeing something like this. So the red areas are very high areas of landslide activities happening, and then the orange areas are high areas, the yellow areas are the moderate areas, the light green is the low, and then the green areas are the very low landslide susceptibility areas. And so this is what we are having for the whole Grenada map. But then when we zoom into where we did the building extraction, we can see places that is having high landslide susceptibility with some buildings located in them. So like this area, you can see a building being in the very high region with 2 or so or more buildings located in the high areas of high landslide susceptibility. So if we turn off the landslide susceptibility tab and then we zoom into those areas, you can see there is a high elevation on that end, and then there might be clay in that region as well. And I think there might be, when we bring in all the land use areas, you can see those areas are having features that promotes landslide happening. And so yeah, these are the things that we are seeing. Let's see distance to rivers. Let's turn this off. Let's see distance to rivers. Yeah, we're having places that are somehow close to distance to rivers. Not so much, but then let's look at the soil types. Let's see if there are clay in that area. Yeah, we're having clay kind of in that area. And so yeah, these places are having areas of high susceptibility, and therefore we know all the features that we put in regards to the elevation type, the distance to rivers and everything is having a good mathematical function to be used when we are doing landslide susceptibility. And so yes, these areas, let's find another area and do further analysis to see if our data is good or not. Let me find a place. I'm seeing this. Let's pick this building and see what is happening on this end. So we will turn off the landslide susceptibility. We just want to look at this building. Let's look at the soil types. The soil type is kind of this color, so it's in a clay loam area. So it's in the clay region. Let's see the elevation. The elevation is high. You can see that the elevation is in a high area. Let's turn the elevation off. Distance to rivers is close to a river. That is why we are seeing somehow close to a river, because the deep blue area means you are closer to an area, but then the whitish area means you are somehow far from the area. And so you can see this is somehow closer, and this place is far away from the river. Let's look at the land use. The land use is green, kind of green. Let's look at the green. Green is it's a forest. So it's forest, but then it's bounded at the boundary. At the boundary, we are having urban fabric. So it means that area has been disturbed somehow at the base, but then we are having the forest that this building is sitting on, and so there's somehow an ability for the forest area to collapse, and so we are seeing that as well. So for me, I would say our analysis that was done, I would say it's about 85 or 90% accurate, and so it can be used. So that is how we do landslide susceptibility. So if you want to export this map that we are having as a TIF format, you just go to landslide, you go to data, export raster data. So what I usually do is I choose here 5, X5 and Y5, and then you click export. And the format, you should remember to choose the format as TIFF. There are different formats that you can choose, and so you choose the TIFF. That will add the coordinates to it. You choose the coordinate that you used as you were beginning this work, and then you click export. So if you click export, you should go to the location that you desire, and then that will be it. If you also want to work on the data, you have to go to the attribute data that is all in the database that was created. You find the attribute data that was created, and then you should be able to have an Excel file to work on that as well. You'll be going into detail on that aspect in our next tutorial. I want to give a special thank you to ArcGIS Pro for this tutorial that they give to us, and being able to share it to other people such as you. I'm so happy for doing this, and I thank you all for joining. See you at another time. Thank you.